Light and color. Each color in the visible light spectrum has its own narrow band of wavelength and frequency. They are beside each other and stick together. So, their wavelength and frequency are in a sequence, one after the other. Light from the sun is a mix of all the colors of the spectrum, obviously, and red, green, and blue are called the primary colors of light because they can be mixed to produce any other color of light. So, the color of the light coming from a light source depends on the type of the light source because it emits its own range of wavelengths. Therefore, for example, yellow-orange light from a sodium street lamp is different in color to the light from the sun because each have different wavelengths. And stars and filament lamps emit white light that has a continuous range of wavelength across the visible spectrum. And at last, lasers and neon lamps emit a narrow range of wavelength. That's how a light source differs from the other based on the range of wavelengths they emit. We've talked about the sources. What about the surfaces? Opaque objects that are non-transparent objects depend on chemicals called pigments inside the materials. They absorb light of specific wavelengths only and strongly reflect other wavelengths. What are examples on this? First, white surfaces have no pigments, so none of the colors or wavelengths will be absorbed. All of them will be reflected, and that's why we see it white. Second, a red surface, for example, as you can see, absorbs all colors except red. Red wavelength is reflected, and that's why we see it red. And what about this case? As you see, if a red surface, for example, is put under blue light, it will look black because it absorbed the blue light and reflected none. So it will appear black. Moreover, also color filters work by absorbing certain wavelengths and transmitting others. For example, if a white light is directed at a green filter, the filter will absorb all the wavelengths and transmit only the green one that we will be able to see. Now, after this, we are able to understand the concept behind translucent and transparent objects. Transparent objects transmit all the incident light that enters the object, and no light is absorbed, while translucent objects let light pass through them, but the light is scattered or reflected so you can't see images behind them. And that's all for light and color.